this year I'm getting a master's in data mining from the University of Buenos Aires also. And I'm mostly working in the industry. I'm a data scientist supervisor at Mercado Libre. And my current interests are in quantum machine learning, reinforcement learning, control theory, and optimization. So why CuPy backend? So CuPy is a comprehensive implementation of NumPy and SciPy on GPU devices. It implements most of the functionalities that are already there in NumPy and SciPy at GPU. CuPy allows us to write the kernels directly, which means we have finer control, and it means that we get better performance. It allows for multiple devices through the NCCL protocol. It has also allows for dedicated memory management, and in particular, it has zero copy exchange with DLPAC. That means that if, for example, let's say we have one backend that uses CuPy and another backend that uses Tensorflow, they will be able to communicate inside the GPU. And then, well, it's also compatible with the plethora of libraries like QDF, which is like pandas for GPU, QML, which is like scikit-learn for GPU, and some more. So our objectives coming to this project were to implement a basic data class that stores the information in CuPy, to implement the specializations for QuTiP's backend functions using CuPy, to create when possible and add more tests implementations, and to assess and benchmark the performance of the new specializations. So basically, some say achievements. If you take a look here in the graph in the left, here what we did was take random matrices, or random, let's say random square operators, and we multiply them, and we have the timings versus the matrix size. We see that, well, the gains are more important as the size of the matrix increases. And from a more involved example, for example, we have the one on the right, where we take a state of n qubits. They are all in the down state. We rotate them, and then we measure the expectation. And you can see that the improvement, the performance is great, especially after 11 qubits, it becomes it's more than 10 times.
I have a question. Your slides, they
yes.
look very dark.
They look very dark.
Can everybody see the slides well, or? Simon, your microphone is off.
Oh, sorry, yes. I said maybe as Nathan suggested, you might see a small watch window which is sort of slightly darkened. And if you click on that, it should become bigger and less dark.
I did, and it looks fairly dark.
I don't know if I can do something from it.
If everybody sees well, then it's okay.
Yeah, for me.
Cool, that looks good from my side.
We can send the records and the slides so that you can also see it better later, Franco.
Yeah, okay. So if you can see, it's fine. Go ahead. Okay, thanks.
Perfect.
Yes, I shall share with you the slides after we finish. So, okay. How does the backend work? Well, the backend works basically built on QuTiP dev, which is now the dev.measure, and then should be, I believe, QuTiP 5. So basically, we have a class that is QPyDense that inherits from the data, which is a class that acts as a backend on QuTiP dev.measure, and then it has arguments where you give an array that holds the data you want to store. It has a shape, 2 dimensions, and then where you want to copy, and then we have also the type, because what happens in GPUs is that there are some performance differences if you switch, for example, from complex 128 to complex 64, but well, you have penalization then on the accuracy of the results. Well, and this has some basic methods that are add, subtract, scalar multiplication, and it has also the in place version of those. Then we have some specialized initializations.
I was able to see the previous slide. Now I fixed it, so I can see it now. Fine.
Oh, perfect. That's good to hear, Franco. Okay, and then we have some basic methods. Then we have some specialized initializations. We have some initializations that do zero copy that are for internal use. And then we have some custom initializations that are basically so that you don't have to move arrays from the CPU to the from the CPU to the GPU.
Not gonna work.
Then we have some extra methods which are here. Most of all the methods that had to be implemented were implemented. We are missing a gem value, the general gem value finder that is not on CuPy. We'll have to implement it at some time. And I'm currently working on the exponential of a matrix that is also not implemented in CuPy, but it's implemented in a lot of other libraries that work on the GPU, like PyTorch and TensorFlow. So I don't know how I'm with the time. Do I need to? I can skip some slides because
yeah, we're a little bit long, but we also lost a bit of time with kind of. So yeah, I mean, if you can wrap up in a couple of minutes, it's probably good.
Okay, so I'm going to go really fast with this. GPUs are mostly parallel and threads that work in parallel, except when they belong to the same warp. So then one has to be careful, because if you have threads in the same warp, they have to start doing the same things. And have to be finicky with that when we did the implementations. And now I'm going to show you some improvements that we did on using CuPy or our own kernels. This is for expectation on density matrix. We got substantial gains for using our own kernel and not using directly CuPy operations, CPU timings. And we did this, try the same for similar things for the expectation, but this time doing an operator against the Brown sandwiching. And the GPU, we didn't get many differences, but then we picked the winner by looking at the CPU timings. Then we had the same for checking if the matrix is hermetic or not. We have to be finicky there, because, well, mainly because of this warp thing, and we have many implementations, and picking the best one by looking at the GPU timings. So some extra features we have there on QuTiP CuPy are that we have, well, for development, we have an automated code style checks. We have a benchmark tool that separates the GPU and the CPU timings. This allows to better know where is the problem, if there's some problems with implementations.
That's good. You can.
And finally, we have some machine functionalities, like I told you. We have function of a matrix not currently working on a GPU, and the gem value not working on a GPU. But that doesn't mean that you can use the package as it is, because what QuTiP's backend does, it dispatches the functions back to functions that run on CPU. So they will occur, but they won't be occurring on GPU, penalized obviously, but they will run. So, and some future possibilities will get solvers to work with this backend, reproduce the same for the CSR data type, that is another data type for the QuTiP backend. We have better support for multiple GPUs. So thank you.
Cool. Thank you, Felipe.